Hello and welcome to our series of building productivity videos for Autodesk Inventor. We've called this series Building Productivity because it's relating to building products and it's workflow based. So we'll hopefully not be just showing you the latest and greatest tools and button clicks inside Inventor, but actually how they can be stitched together into a proper workflow to create the kind of products that you're creating. So for our first video, we wanted to show you a bathroom sink complete with extravagant chrome detailing as you see here. And the Inventor tool in focus in this video is the boundary patch tool. Now don't switch off. I myself switched off the moment I heard the boundary patch tool now has guide rails included in 2017. Was not really that excited about it. But having taken a look at the tool is actually a huge step forward for Inventor in general in terms of its surfacing capabilities, and it may even take the boundary patch beyond the loft tool in terms of power and, more importantly, flexibility. Because the problem with the loft tool in Inventor, or just the way that lofting works in general, is its profiles and rails. And your rails need to intersect your profiles, and if you get that kind of thing wrong, it's not flexible and it's going to kick up a big fuss. Wouldn't it be nice if you didn't have to worry about all that rail and profile business, but instead you could just draw lines that the surface needs to go through, have surfaces that the surface needs to go through, even points that the surface needs to go through, and you just hit go and Inventor figures out a surface that travels through all the correct points in space. And that's exactly what you can do with the boundary patch tool now. So for parametric surfacing inside Inventor, which is what a lot of manufacturers still want, obviously you can use these freeform tools to great effect inside Inventor, but if you want sketch-based geometry, parametric geometry, and you're doing a lot of surfacing in Inventor, then the boundary patch tool is definitely something you should be looking into and watching this video for a start. So before I show you how this sink was created and we draw it from scratch together, let me just explain what I meant just a minute ago about the flexibility the boundary patch tool actually offers. So we've got just a test part here. If you wanted to create a surface that comes off this elliptical surface here and goes through those two curves, that would be very difficult, if not impossible to do with the traditional loft tool in Inventor, but the boundary patch tool does it with ease. You can just pick the loop of edges you want to go through and say guide rails. So as long as it's a surface, you get the option of a guide rails here, and I can just pick guide rail 1 and guide rail 2, and this surface goes through both of those rails, which is fantastic. If we had picked a solid body here rather than a surface, if I cancel out of this and thicken that up, we get another option. We'll be looking at this in more detail, so don't panic if I'm going through this a little bit quickly, but we get another option if that's a solid that we're coming off in terms of the loop of edges. So if I pick that loop of edges, we now get the ability, if I change it to a tangent condition or smooth G2, we get the ability to say, are we coming off at 90 degrees or at 0 degrees? So let's just stick the guide rails on here. And now that's pretty useful. We're coming off at 90 degrees, or well, actually, that's not quite giving it enough space, but we can come off it at 90 or 0 degrees as well, which is pretty fantastic, and apply a weight on there as well. So let me just say OK. But in addition to that, what we could do, if I undo that, is we could add additional stuff that we want to go through. So if I turn on a work plane here, and if I actually wanted to just draw on this work plane here, so if I create a new sketch on this work plane, draw another ellipse or something like that on this work plane here, and boundary patch that one up as well. So just stick a boundary patch on there. I can go through that surface as well. So you can just keep on adding stuff that you want the boundary patch to intersect, to go through, whatever you like. So if I hit guide rails now, there we are. I've got a surface that goes through all the stuff I've told it to go through, and I can apply to each loop, I can apply tangency, and if it's a solid body that I've clicked on, I can apply a angle to it as well, or at least a 90 degrees. There we are, that's the thing I was talking about, 90 degrees or 0 degrees there. So actually fantastically powerful tool here. But let me show you this as part of a bit of a more real workflow. So let's close this part. And let's start creating this off a new part now. Right, so here's my initial profile that I want for this sink. If I was to go into this sketch, we can use the normal Inventor tools for things like if I wanted to stretch it, I can use a stretch tool here. We'll do a bit of this later on, but I can stretch that and parametrically change it. Obviously, this would be fully dimensioned up, but for now, let's leave that as is. Let's turn visibility of it back on, and let's create a top surface using the patch tool. So I'm going to start the patch tool here, just create myself a surface, like so. Right, let's get the control for the bottom of this sink in place. So I'm going to start the plane tool, and I'm going to offset a plane like so, roughly in the middle, not too concerned about that, exactly where it is. So okay, and start sketching on this. So this is precise control that we want to introduce for the bottom slope of the sink. So I'm going to start the line tool, start it from about here, let's draw that down, and then let's just get ourselves a small arc in there. And of course we're going to fully dimension this up, so I'll get my starting height in there, say about sort of 25 mil. My starting distance from the outside, get it in at about 70 mil maybe. Just project in geometry that we need to be able to offset it correctly from this end. Need a bit more than that, I think. Okay, and the angle, I want a 4-degree slope on this, and I also want the bottom to be perpendicular, so I'm going to click this and make sure that that is in line with the center of that circle there. So I need 1 dimension now, and I guess that's going to be the end height of this. So let's just see if we can set the end height here. In fact, I'll get rid of that angle for the moment. Let's just set the end height to be 45 or something like that. Let's make that 4. Okay, that's enough tinkering around. Okay, so that's the exact profile that I want the bottom of the sink to be. Let's just give myself a little bit more space here. Let's make that 100. Okay, fully constrained sketch, happy days. So let's finish that sketch. I'm going to turn off the display of that work plane, and I'm going to extrude this line outwards now. So I'll extrude it both ways, like so. Just extrude it enough basically to cover the available space, and I'm also going to extend it, I think, just in case I need to extend both ends by a little bit more, just so that I can trim to it in a minute. Okay, and now I'm going to draw in the top profile the actual surface that is going to be, or the actual shape of the surface that is going to be the bottom of my sink. Okay, so I've turned on this plane, and I'm just going to use the slot tool. So I'm going to sketch on this plane, new sketch. And I might flip the view, and let's use the slot tool in here. So I'll do an overall length slot, something like this. And dimension this up correctly. So doesn't particularly matter what these dimensions are, although of course they would be important if this was real design. Right, so let's see. Let's find something decent to dimension this to now. I'm going to turn on the display of the original sketch so that I can dimension to a point in the original sketch because I want this to be parametric and to update if the size of the original profile changes. Okay, so I'm going to dimension this this point to a point on the original sketch as well. So I'm going to project in that point, for instance, and just position that relative to it. Okay, and I also want a circle in here that is going to define where the plug goes. Just make sure I get the plug at the right end of the slope, so the plug's going to be going in here. And I may have drawn this whole thing a little bit too small, to be honest, by the look of it. That's a bit of a small plug, but that doesn't matter. We can always scale the whole thing up later. I should have scaled up the sketch, but let's hit finish sketch now. It says one dimension needed, so okay, so I need to define the position in this direction. I'm going to get a dimension in for that. Okay, that's where I want the bottom of the sink to be located. So I'm going to finish that sketch and I'm going to trim the slope surface with this sketch as a trim profile. So let's use the trim command up here. Trim surface. There's my cutting tool. There's the surface that I'm removing. I'll say OK. Right, need that plug hole in there, so I'm going to turn on this sketch and trim again. That's the cutting tool and that's the face I'm removing. Okay, and then I'll turn off the display of this sketch. Right, so now we could start using the patch tool, and I could just patch between that surface and that surface already, and that would allow me to get a surface between the two. But what I want is the ability to put the surface at 90 degrees, and because the loop of edges I picked here is part of a surface, not a solid, I don't have that option here yet. So I need to do a little bit of a workaround at this point, and I actually need to thicken this top surface. So I'm going to thicken it in the opposite direction to which it will eventually be going. I'll just thicken it something large like 20 mil, so that I've got a solid body to work off here. Right, and now with that done, I can start the patch command now, and I can pick these edges, this loop of edges, and I just want to check that if I go to a tangent condition, yes, that's the button I'm looking for, or G2 condition, I can now flip between 90 degrees and flat. Okay, and I also want to go through this loop of edges, so I'm going to pick that loop of edges, and this is what I'm after. So I've got a nice smooth surface between those, but it's a little bit lumpy around this sort of area, and that's because my weighting is a bit high. So I'm going to set the tangent condition also actually on this surface down the bottom. So I've got G2 at the top. I'll set G2 condition at the bottom as well. G2 is curvature continuous, so there's no quick changes of curvature. So it's one better than tangency basically. So I'm going to set my weight here, and I think I need to reduce that to stop this kind of slight crimping of the surface. So if I set that to be 0.4, see what it does with that. Okay, that is a little bit better. Let's see what it looks like in this angle. Okay, that looks pretty smooth to me. So we'll go with 0.4 for the moment, and I'm going to say OK to this. Right, so I never really wanted this solid body. I'm going to turn off the visibility of it up here. I'm going to turn off the display of the plane as well, just by right-clicking on it and hitting V, so I can see a bit better what I'm doing. And I'm just going to use the original boundary patch that we've got there rather than the thickened surface that I created. So that's pretty much my my sink created. The rest is just icing now. So I'm going to hit thicken offset. Oh, excuse me. First I need to stitch them all together. So I'm going to use the stitch command here. Pick all three of those. Get a nice fine tolerance on it. hit apply. And now I've stitched all those together, I can thicken them as a quilt. And it's a bit thick. So yeah, this whole design needs to be scaled up a bit, but I'll go with this thickness here for that as a new solid. Right, that's all thickened up nicely, and so it's really just a case of getting a few chamfers and fillets on here now. So I'll get a chamfer, a distance and angle chamfer on there. Let's get that about 6 mil at maybe 20 degrees. Let's turn off the display of that surface underneath. Okay, I'm just going to get a fillet on here so that I can get that beautiful chrome detailing going on. Okay, and a couple of fillets going around the outside here. Yep, and when that's done, things like the appearance adjustment is quite nice. So I'm just going to do a adjust appearance on this face along here, and I'll just pick the polished black chrome finish for that face, and then I'm going to pick this fillet face inside here, and I want that to be a pure black one as well. Whoops. Let's apply that. And let's just get a nice black appearance on this. There we are. So if we get our view looking a little bit nicer, get the visual style on realistic, it's not looking too bad at all. Now let's just take advantage of the parametrics that we've put in here. So if I go back to my original sketch, we expect that we're going to be able to adjust this using the dimensions that we would have put in here. So if I just stretch this instead, grab this base point here, do a bit of stretching on this profile. Let's say we want to change it to this here. We can create a whole family of sinks, give that a chance to update. Fantastic. Hope you've enjoyed this video as much as I have. See you next time.